Buon pomeriggio, good afternoon everybody, welcome to the Embassy of Italy and thanks for being here this afternoon. Today is an historic day for science globally, and while I want to wish to apologize for the very short notice of the invitation, I hope that you will enjoy this exciting presentation today. Some of you, I know you were this morning at the National Press Club, so you already know what we're talking about. So for the others, I don't want to anticipate what my colleague physicist will say. And with no further ado, I leave the floor to Professor Antonio Masiero, who is the Vice President of the Italian National Institute of Nuclear Physics.
Good afternoon. I'm really happy to be here today. This morning it was said that 400 years ago Galileo opened a new window, a new way to look at the sky.
So we will have a session, Q&A session at the end, I suppose. So now we move to Marco Cavaglia. Marco Cavaglia is Associate Professor at the University of Mississippi, and he's the deputy spokesperson of the LIGO scientific collaboration. So he will tell us details of this terrific discovery.
Grazie, buon pomeriggio. I'm very happy to be here and represent the LIGO scientific collaboration. We are over 1,000 researchers in over 80 institutions in 15 countries around the world. And some of my colleagues are here. Laura Cadonati at Georgia Tech, Maria Alessandra Papa at Germany, Hanover, Alessandro Bonanno in Potsdam. I would like to also acknowledge them because without them I would not be here. Today is a great day in the history of science. And just to put you in context, you have to imagine 20,000 years ago, 30,000 years ago, some people in a cave somewhere and getting out and looking at the sky and wondering what are the stars that you see. Today is a step on a journey to understand the universe around us and the sky. And that journey led us from those ancient people in a cave through first Greek, and then Roman, and then Middle Eastern, and then Galileo, and today. So today what LIGO did, and LIGO and Virgo did, is to really open a new way of looking at the sky. So far, all the information, most of the information we have from the sky comes in the form of light, electromagnetic light, X-rays, radio, or visible light. Then, not too long ago, we learned how to use particles to get information from the sky, for example, neutrinos. Today, finally, we can use gravitational waves to look at cataclysmic events. Gravitational waves are, we call them ripples in space-time. 100 years ago, Einstein told us that the space we live in is not flat, it's curved. And what curves the space is mass or energy. Remember, E equal mc squared, the most famous equation of all. So mass and energy curve the space. And then in turns, the space when it's curved tell object how to move through black holes. So these two black holes have a mass approximately about 30 times the mass of the Sun. Now, this is impressive, but do you know how big is the Sun? It's pretty big, right? So, you have to imagine 30 times the mass of the Sun compressed in a region that is just about 100 miles in radius. Two of them orbiting one around the other, and in a millisecond, in a few milliseconds, merging together to create a black hole, a much bigger black hole. And the two black holes are the two black disks. What you see at the bottom is the depression in space-time that they create. And then they orbit, see, in less than 1 second, a third of a second now from the final merger. They spin with a velocity that is about half of the speed of light until they merge and convert that incredible amount of energy into gravitational waves. How much energy? Well, if we could have seen these gravitational waves with our eyes, the energy of this event would be equivalent to about 50 times the energy in light of all the observable universe. And just to give you, are actually the whoop that you hear, it's actually the sound.
Since the beginning of the history, the man has looked at the sky and has tried to understand the universe by observing light. The progress has been fantastic. The level of sophistication of the optical telescope has been impressive. This is one photo taken by the Hubble telescope a few years ago, and the amount of information contained in this photo is amazing. However, even this photo in its brightness speaks of a dark universe that you cannot access using traditional telescope, because you see there are clouds of interstellar dust that prevent you from seeing beyond. So you have to ask yourself the question, how can break this barrier and go beyond what I can see using the light? This man is Kip Thorne. He's a professor at Caltech, was one of the keynote speakers at the Today press conference. He's also very known to students because he was a co-author of a fundamental textbook about general relativity called Gravitation. And I'm mentioning him because a few years ago he was answering, an Australian student was doing an interview with an Australian student. The question was, what do you think when you look at the stars? And the answer was, I think of all the things we are not able to see up there. 10 years of optical telescope observation to get an indirect evidence of the presence of a black hole there. And this was a really outstanding piece of astronomical work. And now this is what we can see today using gravitational waves. In a fraction of a second, you see a signal that tells you a lot more about the dynamics of
good friend of Francesco Fidecaro. Professor Fidecaro is the chair of the Department of Physics at the University of Pisa. He has been a spokesperson of the clinical collaboration. Many years ago we worked together. So he will show some video about Fidecaro.
So I think we can start the video. You can see on the end there are some Pisan mountains. Those are celebrated by Dante somewhere in his work. And you can see the structure of the two arms there. This is the place where we were. White patch at the end is a cave. It's a Uliveto cave, and it's a Uliveto waters. Some water that is being sold immediately. Otherwise, there are fields all around. There are ponds. Sometimes we have hunters that hunt birds.